when I get told that we couldn't use Cambridge Cottage, I thought, that's all right, we'll survey this and we'll establish it. So I took a quick measurement before I went in to do the lecture of that building there. And it wasn't what I expected. So I went in and did the lecture, came out, and I measured, and I still wasn't sure what was going on with it all. So we measured round a few bits, measured the wall, compared it what I'd scaled off from the Ordnance Survey digital mapping, and it was pretty good. It was very good across there, I think. This one up here, as you can see from your printouts, it was dubious. But the main criteria was this wall here. And this is representative if you're going to do a preliminary survey for yourself, and you're going to access ProMap digital data and then Google Maps. Be aware that there may possibly be errors in it all, which is why you're measuring things to satisfy yourself the survey is good. Now if you look at it, page number 1 was at Orangery, and even though I was going to survey just that bit, I purchased the whole lot. I thought you stole your bike. Page number 2 is with Google Maps shoved on it, so it's the back of your page, right? Back of page 1, yeah? Right, the back of page 1 is Google Maps overlaid, and that's what I was saying in there. What you want to do is, if you've got a site you want to do, and it's simple site, then you can just take a couple of dimensions and draw a few lines and you've got it, right? If it's any more than that, then you want to pay 20 or 30 quid to get, if you think the job's going to be a goer, pay 20 or 30 pounds, get the OS digital data, get it into your system, whether it be SketchUp or AutoCAD, make sure the scale works, and then drop down a Google Maps image on top of it, and that'll give you a good starting point. So then what I did was, as I say, I took measurements off of the Ordnance Survey digital data, and they're in red, all right? And it had 15.368, which is the face of that, right? And I thought, what the heck's going on? That's not 13.68. And it was running around my brain while I was doing the lecture. And I thought, there's something going on here. Either I'm not a very good surveyor, my tape's wrong, there's something else, right? It then transpires that the Ordnance Survey had used the shadow from the sun onto here, and that was their measurement, right? So if I'd used this as a baseline to do other measurements, because somebody was saying, do we need to put in nails? Can we not use buildings, walls, or whatever? Well, if I'd used that end of the wall and this end of the wall, and then tried to relate it to the Ordnance Survey, I'd have been going round in circles, and especially if it was far away. So the job you're doing is a couple of hours away, you take a whole bunch of dimensions, you come back to the office, you draw it all up, and you say it doesn't work. What have I done wrong? Well, you haven't done anything wrong. The Ordnance Survey got it wrong. The line should have been along there, and it's actually along the shadow, and you can see the shadow depicted in the top of the curves on here. Yeah? So then we took other measurements. So the cyan one, what does it say? Let me read it. Yeah, the red dimensions are from the actual ProMap, right? So the red were wrong. So 6.6 metres was that length of that wall up there, but we measured 8.16, which is quite a bit different. But the biggest serious bit was along the back of this, and I measured it at 10.6. So there was nearly 5 metres error, and that's a huge amount. So if you had got the Ordnance Survey digital data and just relied on that, and you didn't get Google Maps to put upon it, and you didn't take any check measurements, you would have thought your property or your back garden was, at this scale, 5 metres, which is nearly 50% wrong. So that can be huge, especially if you're so excited you're going to get your first job and you're starting to measure it all, and you think, this is great, I've got my first job, and then you get caught out with this. So you want to be aware of that you need to put some checks down. And the checks are what I found out. So I went back to the office, started it, and the explanations in here how I went about it. All right. So, case in point is, don't assume anything, right? So you've got, as I say, there's tapes that you can buy. I mean, a decent 50 metre tape is only, I don't know, 20, 30, 40 pounds. You find it in York Survey Supplies. You can buy a distal, that's this thing, right, which gives you a digital readout. So you see the little dot on there, gives me 1.310, right? So it's very quick, but the sunlight, if it's bright you won't be able to see it, but you have got an optical thing, yeah, on there that you can sight through and you can see what you're looking at. So that is about 200 or 300 quid, but it does save you trying to measure over walls and all that, because you can stand, as I say, over there where we're talking about, come up the slope along here and then down to the nail, the control point. Well, you could take a shot from there to the building and measure back in. At least you're getting that horizontal distance, right? So it's a good piece of kit, but you don't want to be spending any money. But you will need to buy some tape, so you're going to buy some small types, 5, 8 metre ones, which are handy. Don't leave them in the long grass, forget them, but it's happened a lot. And get yourself at least 1 or 2 big tapes, because 1 or 2 of the big tapes you can lay it all out straight, and then you can use little tapes to do in your chain and offset your 90 degrees. And who was it asked about how do we know it's 90 degrees, how do you know what the readings are? It'll be obvious. When you've got it 90 degrees, it's correct. When you're off 90 degrees, the distance that's shown against the chain line will be greater. So you're looking for that smallest measurement. And when you get the smallest measurement, it'll be quite easy to see it's at 90 degrees, a right angle. And that's for your easy chain and offset. And I would use that for the close stuff. By far the quickest, easiest method. But it's not the most accurate. The most accurate is the triangulation bit. Trilateration it's called. And then you would measure that, measure again from there, measure from there to somewhere else. So you get 3 parts of the triangle. And if you wanted something else to do your offsets, because it's a little bit further than what you anticipated, you can, that's all right. You can use what's known as these, and there's 2 of them there, you can hand them round and have a look at them. And this is called an optical square, right? So there's a yellow prism in the middle, and that gives you straight ahead. And then there's the top one, which gives you left, and the bottom one gives you right. And if you look through that, you can have a look at them. As I said, 3 of them there. It'll give you an exact right angle, and you want to keep things on straight. So not only can you use this for doing accurate offsets from your chain line when you're measuring in your garden, but you can also use it to verify surveys. Because I could go along the wall of this survey, hold that on there.
Sorry, it's not possible to hear.
Sorry.
What is that called?
It's a double prism optical square. Double prism optical square. They're about £40 at York Survey Supplies. You can get them on eBay as well. It's a really handy piece of kit, because when you're doing a survey, you can line up a pathway or a curb line, or not a face of the building because you can't get on, but although you could use it there because you can step in the doorway. Line yourself up with the edges, so you get the top one and the bottom lined up, and the one in the middle is exactly 90 degrees away. Alright? So you can go along to an existing survey that you've inherited, put this on there, and you can check where the corners of other buildings, trees, lamp poles, building, sheds or whatever, is right angles to where I'm standing at the moment. Yeah? Make sense? So that's a good piece of kit. So you've got tapes, you've got a distal, which is the electronic thing, and you've got a right angle square. Now when you're out, when surveyors are out, they'll have nails. So when you get a survey done, they'll either use little hilty nails like that, 10 minutes, aren't they, planes? Yeah, surveyors will use these, and this is your control point. So this is what they use to put it in. They'll set the survey over it, or they use it for the major control, and they'll measure to it, and that should stay there. You can get longer ones and chunkier ones.
What's the name of those?
Sorry?
What's the name of those?
That's called a Hilti nail.
Hilti.
Hilti, H-I-L-T-I nail. And they use it a lot in construction. But you get different sizes, and they're quite, you can go into tarmac easy, go into concrete easy, and it's a good established point, and it should be there forever. So I put one of these ones, which is a PK nail, it's another survey nail, and that is at the end of the brick sets over there. Away at the end, you can find it on your way out, and I put a Hilti nail on this one beside the corner of the building over there. So I'm surprised that they're still there, because I put them in 3 years ago. So people can think, what's that? And they'll hook them out. And you'll get nosy neighbours that'll sometimes do that, because they don't want to survey, because they think you're going to make an airfield or a roadway or something nearby. But that's what surveys use as control survey points. And it's what you would need for your drone survey, all right, established. They need to come off that, and you can physically measure between it, all right? Wait until that one goes. Right, we measured in there about getting differences in height. So this is an Abney level, all right? You want to have a look at it? An Abney level, A-B-N-E-Y level, all right? It's very light, and what you do is, you have a ranging pole at your height that you want. So you got the end of the slope on the garden, and you measure to the top of that and move the crosshairs to give it the angle. And once you've got the angle, then it can work out telling you what the slope distance is. You measure the pace, measure the slope distance, and with that you can work out what the horizontal is, because that's what's going to plot in your plan. All right. And there's another one that I showed you in the. It's a clinometer, so it works the same way. But yeah, you use the little dial at the side to make the crosshairs go up. Yeah, and that gives you the.
There's quite a few clinometers on the iPhone, but is there a particular software that you'd recommend? Because they seem to be quite variable in terms of.
Well, again, it's all the accuracy in it. Is it 5%, 10% accurate? But at least it's going to give you a good idea, because you're not going to use this kit or an iPhone to level your survey. You're only using it as a guide.
Yeah.
What do I need to think of it? This is rising, if it's that hill away over there, it's about 4 metres high. So it's fine going flat to the bottom of that, then you're going to go up 4 metres, 5 metres. So that can give you an idea exactly what it is, so you can start having that in your design. Then when you come to do the survey, or you're employing the surveyors, you know that you're expecting something about that difference in height when they do the job properly. So it's a guide. But I think that was about, I don't know, 80 quid, 120 quid or something. It wasn't cheap, because again, it's a technical piece of equipment. Abney levels, which are much more robust, sorry, not Abney levels, clinometers, much more robust, but they're probably twice the price. But it'll last you a lifetime. All right. Any questions on any of it? No. Go on then.
Sorry, the one with the laser, is that? Where's it taking the measurement from? Where you're holding it? Or?
You can take it from the back, or you can take it from the front. Get out of it. From the back or from the front.
Right,
See the arrow changing?
Yeah.
So that's from the back, that's from the front. Yeah.
Okay.
So if you're holding it on the edge of a wall or a building, you take the distance there. If you're holding it against something, then you'd want the back measurement. All right.
I see.
But you can look through there and you can actually see what you're pointing to.
Are they the same ones as you can buy for interiors as well?
It's the same thing,
Same thing, yeah.
But they've got so many. Stanley do them. This is this is probably the more expensive side of the market, because they make it survey instruments and all that. Okay, yeah. But it's again useful kit to have. and it saves you having a tape that gets blown by the wind or it's going over humps or whatever. So it just makes it a wee bit easier if you can know where you're taking the distance to. Go on.
This might be a stupid question. Obviously, it's represented as a straight line.
Yeah.
But clearly, it's not. This is undulation, and there's a brick wall at the end.
There
so
is.
what is it? Which bit are they taking as that line?
Sorry?
Which bit are they taking as the line?
Well, the Ordnance Survey, that'll be mapped at, right, your man here's asked about the representation on the Ordnance Survey plan where it's a simple line, because it goes in for the doorway and there's a buttress at the end, all right? Remember, we're talking about accuracy of plot scale. 150 millimetres you can only see at 1 to 500 scale. So if that's been plotted at 1250 scale, there's 2.5 times the error. So what's 2.5 times 150? It's about 400 or 500 mil, 450, something like that, yeah? Because twice it would be 300, yeah? So it's another half again. So 375, best part of 400 mil. That buttress is 250 mil because it's one brick wide. So you would never see it. Because the length, the width of your pen or pencil to do a survey is normally 0.3 of a millimetre. So at 0.3 of a millimetre at 1 to 500 scale is 150 millimetres wide. At 1,250, which is your scale for your title plans and your deeds and all the rest, and that drawing, you can't see anything smaller than 400 mil. So that's why they haven't shown it. That's probably why they haven't bothered showing the, because what they do is when they do the area photography that which they did, as I said, 1920s, 1930s, 1940s, they then had ground control, ground surveyors to go out and map the stuff that they couldn't see, whether there was big canopy overlines or there was big eaves. They had to map where the buildings hit the ground because that's what we're interested in. They would never waste their time doing that, because if they did that as one instance, they would have to repeat it everywhere else. So they didn't. So they're looking at what they can see, the accuracy, what can you actually plot, and what's sensible. Where they did get it wrong was the shadow, and that was never picked up. Probably because it's Kew Gardens, probably because it wasn't interested, nobody's going to build on that, and it was just, why correct? I could write to them and say you've got an error on that, and they would update it and probably thank me for it. So that the next person to come along to tell people about a survey and measure 10 metres and they've got it's 15 metres, and I might well do it, but as I say, I haven't done it as yet. But do you know the identification location, take 3 words. Everybody knows take 3 words. So I'd take 3 words in my house. And I thought, oh, that's interesting, because I'd done a survey of my house using GPS. So I had take 3 words and a GPS point, and it was about 5 metres out, 7 metres out. So I said to him, that's not very good. But again, you're looking at 3 metre squares, I think it is. So I went to take 3 words and said, your mapping's wrong, your grids are wrong. Grid interval, not level grid. And they said, we don't care. Yeah. And I said, why not? They said, well, it's only a representative, it's all relative. So providing the 3 metre square occupies a place that ambulance or emergency get, they don't have it to be accurate. I said, right, fair enough. And then I thought, further than that, the reason that they didn't have it exact is because then they'd have a conflict of interest with the Ordnance Survey Mapping Agency, the national agency, and they could hold them by copyright or something, saying you're using my data, and exactly. So they may have imposed that error by 5 or 7 metres, as they do with the GPS fixes, to cover their backs. I still don't think it's very good, because I would have got it better. If it was me, I would have said, let's put it in the right place. And I did check it again, and so take 3 words is well known over the world, but it's all based on fictitious coordinates, but it's all relative, so it doesn't matter. But anyway, so the object of this exercise was, yes, you can use Ordnance Survey digital data, take a few measurements on it, but be careful that you may find anomalies, but it's certainly good enough for a basis to start doing your preliminary design. All right? And as long as you take a few measurements here and there, you shouldn't go far wrong. All right? Everybody's looking at the double optical prism. Do you think it's good?
Yeah, I wasn't quite sure how to interpret what I was seeing through that. It
Right.
was just like having a multi-screen TV.
All right. Well, let's go down there and I'll show you
happening.
how to do it. So if you find out where that building cut this edge of the brick sets on the survey that I'd inherited, right? So if I use this, in the middle I line up the wall, and in the bottom prism, excuse me, yeah, that's it. In the bottom prism, I go forward or back, left or right, to get the back edge of it. All right, and I can line up the back edge of it exactly the face of that wall, and if it went off that way, you could see it even clearer. I don't know if you're going to be able to see it in there. You'd need to hold it on yourself.
Yeah.
But what you're looking at, the bottom one with a line the edge of that.
So that's telling you whether the wall is straight.
No, I've inherited a survey. I want to know how is that building being positioned relative to the end of this wall or this bit of sets. So I've taken a measurement from there to here.
Yeah.
And I know it's until this plane goes. So on my survey, I can measure from the edge of the sets to here. I can line it up with that, and I know that edge is perpendicular when it's from here, and I can put that on the plan and take a measurement to prove it's all right.
Okay.
So if you look at that, and as I say, you look at the wall in the middle one, and look at the bottom one, and if you move left and right slowly, you can line up the edge of that set. Do you want to try it?
Sure.
So what you want to do is line up the yellow one with the wall perpendicular, so you're moving your body left or right to get it lined up correctly.
Yep, that's fine.
And
I
then
can
on
see
the
it.
bottom one, you should be able to see the edge of this.
Oh, I see. Got it now.
Yeah.
Yeah.
So that's exactly 90 degrees.
Ah.
And you could produce that 180 degrees going that way.
Okay. And then what about the top?
The top
That
one would be the line going to the right.
Because I can just see.
Marco.
Okay, right. Okay.
So when you get it to line up, it's quite
Anyone else
good.
want to go?
And then in January when we do the levelling, we use these to set up a level grid. So we put poles in the ground and we measure 5 metres or 10 metres, then measure, and we can quickly, and I'm talking quickly, set up a rigid grid, and then you fix the edges of the one pole and then the other end, and you can quickly level between them.
So the yellow should be,
Noisy,
wall
isn't
should
it?
be perpendicular. So you know the wall itself.
Now you want to move forward a bit.
Stand in front of me.
Yeah, and yeah. So use the middle one. You can hold it that. Use the middle one to line up the wall perpendicular. So move left or right so you get the wall exactly coming towards you. Yeah.
So line up with the bottom.
No, the middle one, the yellow one.
Yeah, as in the bottom of
No, then
horizontal and vertical. Yeah, perpendicular.
Of the building.
the building you're looking at the edge of
The
it.
vertical.
Yeah, the vertical. And then if Marco moves a little bit this way, then you should be in the bottom one see the edge of this wall.
Oh, yeah. So clever. It's so clever, isn't it? But it's, you have to really squint. You have to have
Well,
good
yeah,
eyes.
but you get used to it. I mean, it's the first time you ever looked through one.
Yeah.
So you want to move. Right, that was my chain line. And I wanted to measure the end of your foot, right? That, if you look at it, the tape measurement is getting larger as I move it through the arc. When it's the smallest, it's almost the right angle.
Oh, so you sort of judge that. You're doing that by
But the further and further away, the less that change in distance is going to affect it. All right. So if you want a couple of things that are far away, you would have to establish another baseline to measure off it, or you can do trilateration, which is the triangles, or you use the right angle square. So you can stand in here, line up the middle, line up your chain line it goes through, and you know exactly what it is. That's where you're going to be. You should get it within that.
You measure on the ground. You measure with it on the ground. Yeah. Not trying to guess.
No, you would go back and forward.
A right angle square is going to introduce an error, right?
Pardon?
If you're holding a right angle square,
Yeah, you're introducing an error.
yeah, because you might not be over your tape measure.
No, but you're going to get it better there than there. Because when you got that thing laid out and you don't know what the right angle's in because there's no other features, you could be anywhere. So this will help you narrow it down to something that's
Put
very
like a
small.
plumb bob off the end of your nose.
You could put a plumb bob, but you can also, if you get soft ground, you put in a ranging pole, and you get two ranging poles that you can screw together. So you put the ranging pole, put the right angle square on top of that, and it's fixed to where it is. We can just move it back and forward. Yeah. So it's just using the skills and using cheap stuff to give you. You know, somebody was saying, well, why do you need a right angle? Well, it can be very handy at times. And you want to see is, you know, where features are relative to this edge, whatever that edge is.
So you know you're on a 90 degree.
One quick question I had. So in one of your diagrams, you took your chain, I don't know, it was like 4.2 metres from that building.
4.7. Yeah.
No, is that just an arbitrary? Why wasn't it closer?
You could have made it. Well, I think the offset to the conservatory is, I don't know, it's 2 metres, 3 metres. So it was only 1.5 metres away from that. But you could have put it on the face of it. But if you want to get your right angles, you know, because there's no point in having it at a funny angle, because you're doing right angles to that window. So you want it square, so it's easier to get the right angle. So whatever you measure off here, pull that chain along, you've got to measure exactly the same the other end. And then you know you're everything's square, then you know everything's right angle. But
I just thought closer would have been easy because you could have touched it.
well, it would be, and it was only a representation. And again, they were alternative about having 3 zeros where you're measuring along the face of the building, picking off the windows, then changing it and going round the face of the conservatory, then moving it back in to continue that. So there's 3 sources of errors. And depending on your plot scale, it might not be, might not be anything to worry about. You know, if you're doing 1 to 100 scale surveys, as we said, it's 30 mil. You know, you'd be a bit bad to lose 30 mil every time. You'd be a bit not very good at it.
Pretty sure I could.
Yeah.
All right. Yeah. Did it make sense?
Yes.
No? Yes?
The only problem was I'm going to do it again now that your header's not there.
Oh, right, sorry.